Okay, so let's say Rand returned 0.37996. What would happen? Again, that's our area to the left. So that's this area here, roughly 38%. Feed that into binomial.inv. Feed in our 22, which is our reservation limit right now, and our 0.9 for our probability of showing up. That gives our x value, which turns out to be 19. We could run it again. Let's roll the dice again. After that, but actually, sorry, before that, let's just talk about this. So again, if we got 0.3799 for Rand, that gives us 19 when we feed that into the binomial.inv, which is our number of people who show up, which will happen quite often. It's pretty likely. Okay, and that means that they're overbooked by one person if x is 19, and there she is. Okay, she's the one who didn't make it on the flight picture in the airplane right now. There's everybody else sitting there comfortably, all 18 people. They're watching YouTube, eating snacks, relaxing before the plane takes off, and we have one extra person who did not make it on that flight. Okay, let's roll the dice again. This time, let's say Rand returned 0.06. What does that mean? That's the area to the left, so much smaller in this case. Feed that in as our Rand here, and when we feed that in, 0.06 fed into here will end up giving us 17 for our x value. Okay, a little bit less likely to happen though. In that case, it means VANAIR is not overbooked if we get x at 17. We have more room, everybody fit in the plane, there's nobody left over, and they're not overbooked this time for this scenario. We could keep going, generating new x values. So we can do this a whole bunch of times. This is the whole kind of backbone of Monte Carlo simulation. You just let a bunch of scenarios happen here where you generate a lot of different kind of iterations of the same thing. Let's do this for a bunch of different flights. Okay, this flight, x turned out to be 20. Rand is 0.66. We ended up with 2 extra people. Okay, this time 0.3799. We're back at the 19 again. When Rand gave us this time 0.999 will give us 22 people who showed up. That's 4 overbooked. Next time we could run it 0.9 if we got for Rand. That would give us 21 in our binomial.inv call. So you can just keep rerunning this and it'll get you different numbers of people who show up every time. And you can use those values in a simulation to kind of see what's going to happen with your flight. Now you don't need to do this if you had just that simple example, but we use that calculation and feed it into a bigger model where there's more other things interacting. So in this case, let's say there's our number who show up, it follows that binomial. It feeds off of our reservations accepted. We put it in right there, okay, and let's say again it was that 17 that we just calculated, and that number who shows up feeds in here as a 17, but then there's a lot more calculations that feed off of that. For example, our cost of overbooking gets associated with that if we are overbooked, and our revenues get associated with how many people show up, and that's totally directly related to our reservation limit. And then you can run this scenario in what's called a data table and run it, let's say 200 times, and then look at your averages and then play with these limits to get to a nice balance between making enough money and not being overbooked too much of the time.